So in this video, I will discuss about SystemVerilog functions. So let's begin. So here is the format of a function. We will first begin with the keyword function and just a second. And then it is followed by the next thing, which is the return type of the function. It can be of any data type and it can also be void. So if the return type of function is mentioned to be void, then that function will not return any value. But still it can return the value using the formal arguments as an output, and I will show you how to do that. So first, for this example, let's assume the return type of the function to be int, and let's name the function anything. Then after that, inside the bracket, we will mention the formal arguments. The formal arguments can have any data type, can have their own direction such as input, output, or in out, etc. After that, we will just mention everything inside the function we want to do. We will mention the functions, the variables, and the conditions that we want to do with those variables. And after finishing that, we will just use AND function. So this concludes the entire structure of our SystemVerilog function. So these functions cannot consume any time. So using any delay literals like that will give an error. And also this function cannot have any blocking statements like procedural blocks and like anything related to like that, like at the rate of postage of clock or any wait block. It cannot have that. It will show error. There can be any return value or non-return value, which depends whether you have mentioned the return type to be void or not. As I have mentioned earlier, if the return type is void, then the function will not return anything. And the SystemVerilog function executes at simulation time 0. So I will help you understand SystemVerilog function in a better way with the help of a very simple example. So let's begin. So I will write a function which will divide numerator by denominator. So I will begin with the module name. I will name it test. Then inside it, I will mention three variables of int data type. So the first two variables will work as numerator and denominator respectively, and x variable will be the output. It will just take whatever the function is returning. Now I will begin with my function. So the return type of the function should be int, and I will name my function divider. And I want my function to have two arguments, that is numerator and denominator. So I will also use AND function keyword. Now I will begin. So first I will mention a condition that if denominator is equals to 0, then it will display invalid. And it will return 0. And my second condition will return numerator by denominator. It is very obvious. So as you can see right here, it's a very simple function which takes two formula arguments that are numerator and denominator. And if the denominator is 0, it will just show an error or a display prompt which will say that the denominator is invalid and it will return 0. Else it will return the actual divide between numerator and denominator. So this was our function. So let's begin with the initial block. So I will first write an initial block to continuously monitor the value of x. So it will print the value of x if it detects any changes. And using my another initial block, I will provide the stimulus. So let's give 12 to A and 4 to B. And let's assign x equals to, and let's call the function. So our numerator should be A and our denominator should be B. So as you can see right here that we have a valid denominator and we are expecting 3. So x will just get the return type, the return of this function, and the answer should be 3. So let's go ahead and check for any possible compilation error. Okay, there is an error. Yeah, I forgot to mention and for this if condition. Now it should work. Okay, now there are two errors. Wow. Okay, so because of my failure, oh, it should work. Yep, it worked. So let's go ahead and simulate the code. Okay, so we are getting 0, and it is because of the fact that I did not mention any any data type for the argument, which is wrong. So I will go ahead and mention int to be the data type of both the formal arguments, and then I will save the code and run it for one more time. So just remember to mention the data type of the formal arguments. It is a very important step. This time we should get 3, hopefully. Yes, we are getting 3, is the correct answer. So let's move on to the formal argument section. as you can see that it is very important to mention the data type, and also by default the direction of each formal argument should be int input. So if I do not mention anything, the direction is input by default. So if I mention input here, it will not cause any change. And remember, both the direction and the data type applies to both of the arguments until unless I mention them to be of different direction. So we can also use the different direction, like I can also mention the output here, and I will show you right here. So instead of doing that, we can just modify the function, and that function will not have any return type. So I will mention the return type of that to be void, and so using that we cannot use return, so because this function won't be returning anything. But instead of that, we will mention one more formal argument, and I will give that argument the output direction, and it will be of int data type, and I will name it out p. So instead of using return here, we can just assign the value to out p. Similarly here, we can just out p. Now, since this function has three formal arguments, we have to modify our initial block that is providing the stimulus to the duty, or not to the duty, just to the function. So it is just calling the function, and what I will do, since it does not have any return type, cannot assign it to any variable. Instead, I will just mention x to be the third argument, which is output, and it should work just fine. So as you can see right here that if the denominator is 0, the x will get passed to here and it will get 0, and we will get a display message showing that the denominator is invalid. Otherwise, we will get the fraction between the numerator and the denominator, and the answer will be assigned to output. And here we are passing x as an argument, as an output to this function. So let's go ahead and run the code. First, let's check for any possible compilation error. Okay, the code is working just fine. So you can see that the monitor initial block detects the change in x, and it just displays the value of x. So even with no return type, we can still assign, we can still get the value from any function in SystemVerilog by assigning one of the argument as an output. So that's the thing with SystemVerilog function. It is very flexible. So other than that, we can also pass values by a name, which is very similar with the port or the duty instantiation in the test bench. So we can just write, let's say if I want my output to be x. I can mention it right here. There is no requirement of any lexical argument or a lexical order of arguments, which is the case for Verilog function. But here you can just go ahead and assign the values using this dot notation to any of the argument. So I'm assigning output to x. Similarly, I can assign, let's say, numerator to be a and denominator to b. And it's just the same. It will work just fine. So let's go ahead and check for any compilation error first. Okay, now let's go ahead and simulate the code. So as you can see right here that we are getting the correct value, and it is very similar to module instantiation. We can assign the value in this way. Other than that, we can also assign some default value to any formal argument present inside this port declaration or whatever it is. So we can assign any default value. So for our example, let's just say, and also since I have already mentioned that the default direction of all the formal arguments is input, I could just read this input and it will work just fine. So let's go ahead and just write anything. Let's say, let's give denominator the default value of 0 and numerator the default value of, let's say, 2. So what is happening right here that if you provide a default value to any formal arguments of a function, then it is not necessary to assign value when you call that function. If you do not assign the value to a particular functional argument, a formal argument, then that formal argument will use its default value. So I will demonstrate this. And on the other hand, if you haven't mentioned any default value, then you have to assign some value to that formal argument. Otherwise, you will get a compilation error. So for this example, let's say I am not assigning any value to both numerator and denominator. And I'm just assigning output. So let's see what will happen. We'll save the code. I will check for any compilation error. Okay, the code is working just fine. Now I will simulate the code. Okay, as you can see right here that our function is working just fine. We are getting 0 assigned to because of this condition, since the default value of denominator was mentioned to be 0 and we haven't specifically mentioned any value of numerator and denominator, it will just use the default value. And here I have the condition that if denominator is equals to 0, then the output should be 0, and it will also display the invalid denominator message, which is mentioned right here. So there are lots of things that you can do with functions. Other than that, we can also pass the value by reference. So if we use something like a ref keyword, so what we are basically doing, we are passing the pointer of the caller of the function to the function itself, and any modifications made by the function will be reflected on the caller's variable. So let me show it to you. Suppose if we want this output to be passed by reference, we will just use a ref keyword, and I will not use output. I will just use the ref keyword and it should work. So what we will be doing right here is that we will be passing the pointer of the variable x to this function, and it will make some modification depending upon the value of denominator, and then that modification will be reflected on the output x. And it is because of the fact that we are not passing a copy of the value. Instead, we are passing the pointer and we are referencing to the same memory location. So let's begin. This time I will just go ahead and assign a value, assign a to be numerator, b to be denominator, and x to be output. This time this function is not returning any value, and also this function does not have any formal argument as an output. Still, this change will be reflected because of this ref keyword. So go ahead. Also, there is one more thing that I would like to add, and it is very important that the task or function which has ref keyword used to its formal argument should be automatic. And it is very important when you are passing a pointer of a variable to a task and function. It should be automatic and the instances should be called. And also, since we are using the function inside a module, by default, all the tasks and function will be static. So let's go ahead and check for any compilation error. Okay, now let's go ahead and run the code. So as you can see right here that the code is working just fine. This time, the first time we have a return value of int, and then the second time we were mentioning one of the formal argument as an output, but this time we haven't mentioned any direction. Instead, we just pass the pointer of one of the variable here inside the module test to this function, and we made some changes to that variable, and that change reflects back on the the variable which is outside of that function. And the last thing which I would like to discuss is the read-only reference argument, and it is just writing a constant keyword, a constant keyword right before the reference keyword. And for this case, it will show an error because we cannot make any modification to any constant. So I will rather use it, let's say right here or right here. So what this does, it just passes the pointer from the caller variable to this function, but it does not make any changes. Since it does not make any changes, no changes will be reflected outside this function, which is obvious. So we are just passing the pointer, and using this constant keyword, we are making it sure that we won't be making any changes here. So a question arises that what is the use case of this? We could just use, we can just mention nothing right here and it will do the same thing. But it is for the optimization's sake, we will use this because suppose if we are passing or if we are parsing our data of large array or array of struct, it will take a lot of time to copy the values for the variables because in the regular functional argument you are just copying the value, passing the value directly to that function. So for very large arrays and structs or whatever, it will be very less optimized. For this reason, we will just pass the pointer to that function and we will parse the data and we will perform whatever operations we want to do with the retrieved data. So that's all about functions. I hope you find this video useful. Please stay tuned for more. Thank you.